Good day everyone, I am Hock Seng and today I would like to do my major presentation on Earthwork. For our Earthwork department, I have one partner, Ji Shen, who is working together with me along the project. In the presentation, there are some contents I would present which are introduction, objective, poster, site inventory, site analysis, proposed level, cut and fill, cross-section, slope stability, and conclusion. What is Earthwork? Earthwork is the first phase of any construction activity in the development of project. It involves excavating the existing land to a designated level before the commencement of any development. The process of earthwork includes excavation, grading, temporary shoring, cut and fill, compaction, and lastly, disposal. There are three objectives. First is to determine the proposed level of the site. Second is to estimate the volume of cut and fill based on proposed and existing ground level. And third is to determine the gradient and stability of slope. This is our department poster and we have provided some comments in the report. Site inventory. It is a process of collecting data and information on natural and human features in particular area proposed. In this stage, the area of the project site can be determined, which is approximately 47.75 hectares. The existing level also can be determined. The highest level is 88.99 meter located at north direction in our project site, while the lowest level is 32.53 meter located at southwest direction in our project site. The existing land where mostly the land is covered by oil palm plantation. There are also some existing features such as toll station, bus stop, and etc. By using application Google Earth, we can approximately know the area of project site, which is 47.75 hectares. Since the pandemic of COVID-19, we have to follow SOP and we don't have a real experience to a site visit. So my partner and I decided to use Google Maps with instant view to look around the site. Some existing features we have observed, which are electricity junction box, manhole, covered, bus stop, steep drain, toll station, and water pipe. Site analysis. This is the analysis of the site with respect to many factors involved in construction. At this stage, the drainage is designed based on gravity flow, so we no need to install pump. For water tank, it is located at the highest reduced level to facilitate the gravity flow. The sewage treatment plant STP and water retention pond WRP is located at lower reduced level to perform capable operations. For example, STP is required to speed up the natural processes by which the water is purified, while the WRP is required to store more water flow through. This is our topography plan and development plan. There are some information we can extract from the site analysis. The highest level and lowest level are at the position shown in the figure. We also observe that there is an accumulated pond existing, so it must be removed before moving to the next phase in order to ease the cut and fill process. Next, there are three main entrances proposed at the location shown in the figure. So I believe that there are some wondering in your mind why the main entrances are set at those positions. Can I randomly set the proposed level for main entrance? Well, I will explain them at the following slides. By using the instant Google Street View, main entrance 1 and 2 are preferred to set at the existing T junction, and main entrance 3 is set near to the toll road, but we need to relocate some of the utilities to make the entrance possible access at the location proposed. This is the proposed level for our site. We can notice that the purple color indicates the highest level and location of water tank. So, with gravity flow, pump is not required and cost of our project is reduced. Selection of proposed level at main entrance. By looking at the left figure, the existing road level near main entrance 1 is between 39 to 41 meter, and our proposed level for main entrance 1 is 39.5 meter, so it is acceptable. How we make the selection? We must make sure that the level of main entrance is puncturing the existing road level to provide better visibility for driver. We must avoid steep slope at the main entrance that might cause danger to driver, especially for the heavy vehicles like bus and long trucks. Lastly, more than 3 meter difference between existing and proposed level is not recommended. This is our trend of proposed level for each zone. For Zone 1, the proposed level reduced from left to right, while for Zone 2 and 3, the proposed level reduced from right to left. When we cut horizontally at that section, we can get a V shape. For sewage flow, the sewage from Zone 1, Zone 2, and Zone 3 is flow to the STP shown in the figure. For water flow, water from Zone 1 and Zone 2 is flow to the WRP near main entrance 1, while the water from Zone 3 is flow to the second WRP shown in the figure. Cut and fill. So what is cut and also what is fill? Cut means that when the original level exceeds the proposed level, and fill means that the original level lower than the proposed level. It is good if the volume of cut greater than the volume of fill, because we not need to import the earth from outside, which will cause a time-consuming problem. We are also able to save the transportation and material costs. Calculation on volume of cut and fill is ready to be carried out, and second trial is needed when the percentage difference of cut and fill is higher than 5%. This is the grid layout for cut and fill calculation. The left part is taken by me, while my partner G is taken the right part. Green color indicates development and yellow color indicates load. Our grid is more implemented compared to just using the symmetrical grid. Our grid is follow the development, but there is one thing we must consider, which is the dimensions of the grid must less than 50 meter and the total area of grid must less than 2,500 meter square. Example of calculation using grid method. I will take grid B91 as example. The first step is we need to investigate the original ground level OGL for each corner. At top left corner is 36.4 meter, at top right corner is 35.8 meter, at bottom left corner is 39.8 meter, and bottom right corner is 39.1 meter. By using AutoCAD, just type area in the command and we can get the value. The proposed level at this grid is 41 meter. The third step is obtain average OGL by sum up the four corners OGL and divide 4. The fourth step is to calculate the difference in height using the average OGL minus proposed level. Volume is calculated by multiplication of difference in height and area. The negative volume indicates fill volume. After we repeated the same steps for all the grids, we can get the total cut volume and total fill volume. The percentage difference is calculated and 11.85% is resulted. This is example on how we do the spreadsheet in Microsoft Excel. From the first trial, the percentage difference of 11.85% actually is slightly higher. So we have to carry out the second trial by increasing the proposed level from first trial at Southern Zone. Therefore, the percentage difference is 4.84%. By inspection, it has a significant reduction on the percentage difference we get. So second trial design is adequate. This is cut and fill coloring. Green color indicates cut zone, red color indicates fill zone, and white color indicates free space, which is also be untouched area. Cross-sectional view. This is cross-section of northern zone. Similarly, green color indicates cut and red color indicates fill. This is central zone. This is southern zone. Slot stability. Slot stability analysis is a static, analytical, or empirical method to evaluate the stability of excavated slopes or natural slopes in soil and rock. It is one of the key elements in every construction project to prevent the occurrence of slope failure in construction site. Slot stability is based on the interplay between two types of forces, driving forces and resisting forces. Besides, Our construction site has a hilly topography and it will put the environment at risk by natural disasters such as landslides and becomes a safety threat to the life and property. Therefore, analysis of related slope must be carried out. For the design slope in this project, we should follow Bishop method to find out minimum safety factor that satisfy the requirement. Bishop simplified method. The simplified Bishop method uses the method of slice to discretize the soil mass and determine the factor of safety. This method satisfies vertical force equilibrium for each slice and overall moment equilibrium about the center of the circular trial surface. Since horizontal forces are not considered at each slice, the simplified Bishop method also assumes zero interslide shear forces. Factor of safety for a trial failure surface can be calculated using the equation shown. Left-hand side and right-hand side have factor of safety parameters, so trial and error is needed to be carried out to find an accurate factor of safety. These are the assumptions on bulk unit weight of soil, specific gravity, cohesion of soil, internal frictional angle, and pore pressure. Those formulas might be used in the calculation. There are three types of failure: toe failure, deep slip circle failure, and slope slide failure. When radius increases, it is categorized as deep slip circle failure. While the radius decreases, it is categorized as slope slide failure. This is the calculation for toe failure, and we get factor of safety equal to 1.72 by assuming the initial factor of safety equal to 1.53. This is the calculation for deep slip circle failure, and we get factor of safety equal to 2.07. This is the calculation for slope slide circle failure, and we get factor of safety equal to 1.75. A graph of factor of safety versus radius is plotted. The range of factor of safety obtained is between 1.7 to 2.1, which is more than 1.5, the minimum factor of safety stated in MASMA. Therefore, slope ratio 1:1 can be implemented to our project. In conclusion, our Earthwork department have been successfully done the site inventory and site analysis, provided a proposed level layout, performed cut and fill calculation, and lastly completed the slope analysis. At the end, all the objectives are achieved. We have finished all the stages on Earthwork site planning, include cut and fill calculation and slope stability. For teamwork, I have fully cooperated with my partner G to complete all the job scopes, and we successfully produced the best report. Lastly, I would like to appreciate and thankful to Sir Ashad for his guidance throughout this project, especially all the sharing sessions on every Wednesday morning. Hope Sir can enjoy his life after the retirement on this year. That's all from my presentation. Thank you.